All right, students, in this next example, what we're going to do is we're actually going to look through here another example for inducing EMF in some material. Now, in the first example, we had a coil of wire, and when we first started to look at this topic, we had an example here where you had a metal bar in a circuit, right? So if we had a circuit here with some bars and maybe a resistor, okay, and then you slide this bar across the wires here, the kind of rails, then what this did was this changed the amount of flux inside of the window, and this generated an EMF, right? So if this seemed a little bit strange, we can actually show in another way how this is actually done, right? So let's start with just the example here. This is the first example, what we did. We showed that the faster you move this bar, the more your flux changes every second, which means we have more EMF. So let's go ahead and try this out. If we do this, so here I have a very simple formula. It is just negative magnetic field times length, the length of my bar from top to bottom here, the length, up here my circuit, and then my speed times V. So let's go ahead and try this out. My speed here is going to be 30 meters per second. My magnetic field is going to be 5 times 10 to the minus 5 Tesla, okay, on the order of the Earth's magnetic field. And then, the length of my bar will be something like 2 meters. Okay, so let's go ahead and try this out. We'll go ahead and right here, this is going to be magnetic field is 5 times 10 to the minus 5 Tesla. The length of my bar is 2 meters, and the speed that I'm moving it at is 30 meters per second. Okay, so putting this in here and putting this into our calculator, we get, about 3 times 10 to the minus 3, okay, and this is my EMF. So very simple, no algebra we have to do anything, just to start us off, right? And remember my units here, this EMF, this electromotive force, is a potential difference. It acts like a power source, right? So this is volts. Remember that this is volts. Okay, so we have our answer. First answer. So this is fine for the formula. But here, in this case, I actually don't have a circuit, right? I just have a bar that maybe I'm just flinging it through space. Now, there's magnetic field, like maybe the Earth's magnetic field is just in the background. We're kind of facing here from south to north, okay? So the magnetic field is going into the screen towards north. And you just fling a bar from left to right, and this should still create an EMF, even without being attached to a circuit. So how does this actually work? If you remember my Lorentz force from part 2 of the course, this is the force on a charge in a magnetic field, and it was Q V cross B, okay? So pretty much if I have a charge in a magnetic field, then based on the speed, okay, and the charge, I will generate a force. We started using the right-hand rule to do this, right? So I'll generate a force on that charge. And so let's go ahead and look at this. This does actually work on this bar, and we can show exactly how this becomes a power source, right? Without even being connected to a circuit. So imagine here that I have some positive charges inside of my bar, and of course I have negative charges inside my bar as well. But just when the bar is sitting still, it's neutral, so it has the same amount of positive and negative charge, and they're pretty much evenly distributed, right? But now I fling these through space, okay? So what I'm going to do here is I'm going to start with my positive charge, because this is the right-hand rule. If my positive charge is moving in this direction through my magnetic field, which is into the screen, then I want you to use your right-hand rule to show what direction the force will be in on this particle. Okay? So go ahead and try it out. All right. So hopefully you guys got this. So what we're going to do, we're going to take our thumb in the direction of the speed, right? So, or the velocity, sorry. So thumb will be pointed to the right here on the screen. And then your fingertips will be pointed into the screen. So into the screen for your fingertips. And if you've done this, you have your right thumb pointed to the right and your right fingertips pointed into the screen. The palm of your hand will be facing upward, which is like you push the charge upward. This is the force on the charge. It'll be forced upward. And this will actually happen for each of these charges. Okay? Now, conversely, right? We kind of move these, so we give a little bit of space to show this. Let's see if I can, there you go, something like that. Okay, so I can also do this to my negative charges, but my negative charge, remember, acts opposite of my positive charge, so we actually just use the left hand. So you have your left hand using the right hand rule with your left hand for a negative charge. So if we do the same thing now for my negative charge, and I have my negative charges now moving to the right as well. All of my charges are moving to the right, right? So my negative charges are also moving to the right. But now if I use my left hand, my left thumb points to the right. My left fingertips point into the screen. And then what I end up with here is that my force is what's going to push my charges, my negative charges, is going to be downward. This is going to be the force, and I'll put a little negative sign on it, and I'll put a little positive sign on this so we remember, okay? But this negative force will act downwards on all of my negative charges. So what I end up with, essentially, okay, if I grab here, I make my bar right here, what I'll end up with will be my positive charges will start to aggregate at the top, and my negative charges will start to aggregate at the bottom. Okay, and this is essentially, this is a battery, right? This is a battery where I have, you know, a positive side and a negative side. I just have potential difference, right? It's literally potential difference. I have more charges, positive charge on the top and more negative charges on the bottom. So there is some energy here, right? And then of course, if I connect these, last little piece, if I connect these with maybe a resistor or something, then I will create a circuit. I will create a current flow through here. So this is just an alternative view of how this works for inducing EMF in materials.